So lithium hydroxide and HBr, hydrobromic acid, LiOH and HBr, when they react, it gives LiBr and H2O. Now, if you start with 10 grams of lithium hydroxide, we need to find out how many grams of lithium bromide will produce. So we start with 10 grams of lithium hydroxide, 10 grams, and we need to find how many grams. So this is mass to mass stoichiometric problem. Mass of one reactant given and mass of other product, so it's mass to mass relationship. Okay. Now, once you have 10 grams of LiOH, you convert into moles of LiOH. And you know that 1 mole of LiOH, which will, what's the formula? Molar mass of LiOH? 24 grams of LiOH. That's the molar mass. Okay, so we convert from grams mass of LiOH to moles of LiOH. Okay, now this is a balance equation. When you compare, this is a balance equation, and the mole ratio is 1 to 1. 1 mole of LiOH used up and 1 mole of LiBr produced. Alright, so we can say 1 mole of LiBr produced while it's using 1 mole of LiOH. When you do that, moles of LiOH cancel and you get moles of LiBr. Now remember, we need to convert moles of LiBr to grams of LiBr. Now whenever we multiply by molar mass of LiBr, 87 is a molar mass of LiBr. When you do that, you cancel moles of LiBr and finally you get grams of LiBr, and which is going, when you calculate 10 times 87, 870 divided by 24, you get 36.24 grams of LiBr. So in this case, 24 is a molar mass of LiOH and 87 grams per mole is molar mass of LiBr. In between we are using this mole ratio. So first we convert moles of LiOH, then using mole ratio we convert moles of LiBr, and then we can convert into mass of LiBr. So that's a mass to mass relationship. Okay. We are going to take one more example on mass to mass relationship. Okay. I'm going to give you the equation: magnesium plus 2 NaF, and it gives MgF2, and it produces 2 moles of sodium. Now here it is saying if you start with 5.5 grams, 5.5 grams of sodium fluoride. You start with that and you need to find out how many magnesium fluoride you get. So I'm going to write just a question mark. You need to find grams of MgF2. So again, this is a mass to mass relationship. Mass to mass relationship. So first, whatever the grams given, we convert into moles, and then multiply by its mole ratio, convert to moles of MgF2, and then we can convert into grams. Okay, so in this case, let's say if we have 5.5 grams of NaF. This is we start with, this is given. Now we know that 1 mole of NaF, what's the molar mass of NaF? When you calculate, you get 42 grams of NaF. Alright, so we cancels gram and we convert it to moles of NaF. Now next step is we need to convert from moles of NaF to moles of MgF2. So there is a 2 to 1 mole ratio. So when 2 moles of NaF used up and it produced 1 mole of MgF2. So that's the ratio we multiply. So that way we convert moles of NaF to moles of MgF2. Alright? Then we will again convert moles of MgF2 to grams of MgF2. How do we do that? We are going to multiply its molar mass, which is 62 grams of MgF2 per 1 mole of MgF2. Now when you check MgF2, moles of MgF2 cancel, and now when you calculate 5.5 grams times 62 grams and divide by 42 grams and 2, you get about 4.06 grams of MgF2. So you start with mass of NaF and you convert mass of MgF2 in this particular reaction, and that's called mass to mass stoichiometric problem.